ISIS optimization with hello padding feature. In this video, I am going to talk about one of the neighborship requirement, and after that the hello padding feature, how we can use this feature for optimizing the usage of their resources, for example bandwidth and maybe CPU of the routers. Let me to talk about first the MTU requirement of the neighborship. You know that in ISIS we need to send LSPs from one router to other router to informing the routers, the neighbors, about the linkage states of the one router. And this is the mechanism of the ISIS, sending LSP to each other. In ISIS, we have a consideration, and we need to ensure that the MTU of the interfaces in two sides of a link should be equal, the MTU or maximum transmission unit. Why? You know that the MTU or maximum transmission unit of one interface is equal to the maximum packet size that interface can send. This means that when you have the MTU of 1500 byte, this means that the biggest packet or the biggest PDU that can send from this interface is 1500 byte, and you know that this is the size of packet. Maybe we can send a little more for a frame, okay? And because of that, why we need to say using the same MTU in both sides of a link? Because we have a consideration in ISIS. In ISIS, every router should try to use the full LSP for using the better for using the resources better. For example, when R1 needs to send 3,000 byte, okay, for example R1 needs to send 3,000 byte of information, okay, it needs to send two LSP. Both of these LSPs now has the 1500 byte. Because of that, we can send the information with only two LSP. But if you use the 1000 byte LSPs, this means that you need three LSPs. Because of that, it's better to using the LSP with full size to sending the LSPs faster, and also using the less overhead for the advertisement of LSPs. Because of that, in ISIS, we need to send LSPs with the maximum size of the MTU, to ensuring that we are using the best practice of the bandwidth between the two routers. Because of that, we have one consideration. The consideration is that if I should send the packets with maximum MTU size, R2 can receive these packets because of its MTU. Assume that in R2 we have the MTU of 1400 byte. If I send the LSP with the size of 1500 byte, the R2 can't receive the packets because this is bigger than the MTU of the interface of R2, and because of that, R2 should drop the packets. And finally, ISIS, because of this consideration, uses the MTU equal between two routers as a requirement for neighborship. In ISIS, when you are configuring the MTU different between two sites, you will lose the neighborship. Let me to show you. This is our scenario. Between R1 and R2 we have neighborship, show ISIS neighbors. I configured this scenario before, and also show interface serial 10 can show us that the MTU of this interface, the MTU of serial 10 is 1500 bytes. And if you use different values for MTU between the interface in both sides of a link, you lose the neighborship. Let me to show you here, conf t. For example, I'm using interface serial 10. This is the serial 10 of R1, and then using MTU with the 2000 byte. Look at here, after the hold down timer, we lose the neighborship. Do show ISIS neighbors. Look at here, the whole time now is 27, 24, 23, 21, then 29. It's okay, but in R2, let me check the R2, show for example ISIS neighbors. In R2 you can see that the